You can always jump in anytime during the lesson and be like, I don't understand what's going on. So, today's lesson is this here. It says POI. This is points of intersection. So we're looking at points of intersection, like as in lines, and we're going to use a specific method called substitution. But we'll get to that. So to get started, I'm going to go through this little warm-up here. So the warm-up is graphing these two lines below. So let's go back to what hopefully we can recall. If we think about this, I'm going to put it on here. All right. So, equation of a line, y equals something x mx plus b. Now, if we recall, the letter m was our slope, and the letter b was our y-intercept, or the initial value. Now, let's plot both of these lines on the grid, on the graph. So if we look at our graph here, we have our y-axis right there, and then we have an x-axis right there. Okay, so let's start off with this one right here. If we follow the method of y equals mx plus b, right, I'll put it off to the side there, that means that this 2/3 here is our m. Hold on a second. My lesson kind of disappeared on the bottom. There we go. Okay. Okay, so there's our slope right here. And then we have the other part, which is this right here, this -3. That is the y-intercept. So we're going to put that on first, because that's going to be our starting point. All right? And the last thing about slope I want to point out is that slope is equal to rise over run. Right? So that means that this 2 is the rise, and the 3 here is the run. All right, so let's go back and we're going to put that point on now. So we're going to start off the y-intercept at -3. So we have to go to y equals -3. There's -1, -2, -3. All right, so here's one of the points. That's one of the points. And then we're going to use our slope, our right up here, this 2/3 slope, and we're going to use that on a rise and run. So we're going up 2, right, plus 2. That's our rise. And then our run was 3. So we're going to go over 3. So that means that this point right here is the next point. So now we have 2 points. And we could do the same thing. We could add another point on. It follows the exact same pattern, right? So it goes up 2 over 3. So this point is on the line as well. All right? And so we can graph that line by going like this. So the trick to graphing any line, if you're given the equation, is start with the y-intercept, and then start with the y-intercept, and then you go by the slope to get the next couple points. All right, so there's our line. Okay, so that's our line right there. That one is y equals 2/3 x minus 3. Okay. All right, there's the one line. Now we're going to do the other line. Same idea. We have to find the y-intercept, which we have right there, plus 5. And then, so plus 5 is going to be right there. And then we're going to use our slope, negative 2. Well, negative 2 is just really negative 2 over 1. So there's our rise. And there's the run. Okay, so we start at this point here, and our rise is down 2. So we go down 2 over 1. Right there. Down 2 over 1. Down 2 over 1. So we should see that we're getting an intersection here. So I am going to connect that line. Right there. And I'm going to label it because it needs to have a name on the map, on the graph. And I'll just color it just to make sure it's clear which one is which. Okay, so that brings us to the next key idea here, which is that we have this. There's the point of intersection. So we can see that these two lines meet, and we want to know what the coordinates are. We want to list that. So the point of intersection with the coordinates, if I write them in, so I have 1, 2, 3 is my x. And it goes down 1, so it's 3, negative 1. So I'm going to put POI at so our point of intersection is at 3, negative 1. All right, so by placing those two lines there, we can see that they're intersecting at a certain point. So we could do that by graphing them each time, but that takes a long time to do it that way. So we can do find the intersection without actually graphing. So this is finding intersection by graphing. But if we want to find the intersection using something called substitution, well, it has to follow a certain rule. So in this case here, that we're going to find the inner point of intersection between these two lines. So we have one line that's right here. We have another line that's right here. So if we have two lines and we want to assume, if we assume that they both meet at some point, at some common point, right? They have to meet at some point that they have in common. Then we can say that at some point x, they have the same value y. So essentially what we're trying to say is that they have a common point. They both have to exist at the exact same point. So if that's true, here's what we do. Step 1. So we're going to say let y equal y. What that means is equation 1 and equation 2, y equals something, right? So in this case here we have y equals this. And in this case here we have y equals that. So what we're going to do is we're going to take the first part, 3x minus 1, and it's going to be equal to negative 2x plus 4. There's the 3x minus 1. I'm going to put it in yellow. Shows you that's equation 1. And here's our negative 2x plus 4. So all we're doing to find this intersection is we want to get all the variables with the letter x on one side of the equals sign and everything that's just a number on the other side. So let's look at this equation here. If we have 3x minus 1 is equal to negative 2x plus 4, I want to get rid of this negative 2x. So I'm going to add 2x. So these two now cancel each other out. But whatever I do to one side, I must do to the other side. So I end up with 3x plus 2x minus 1 is equal to 4. But I also want to get rid of the number on this side here. I need to get that to the other side. So if that's minus 1 on this side, I'm going to add 1 on this side. Whatever I do to one side, I have to add to the other side. And the minus 1 and plus 1 will cancel each other out. So what I am left with is 3x plus 2x is equal to 4 plus 1, which I can then simplify. 5x equals 5. All right? So if 5x equals 5, which value of x we have left? So once we're in this situation, you divide by whatever's attached, right? The 5's cancel each other out. X equals 5 divided by 5, which is just 1. So the last part here, step 2 is insert the value of x into either equation. Okay, so we can pick either equation 1 or equation 2. Let's pick equation 1 for a second here, right? So we had y equals 3 minus 1. And the value for x that we got was 1. Right? X equals 1. There's the 1. So now we can evaluate this. Y equals 3 minus 1. Y equals 2. So that's our second point, or our second coordinate. So now we have the coordinates for x and y. So we can finalize by saying we're going to identify the coordinate by saying, therefore, point of intersection at our x coordinate 1 and our y coordinate 2. That's it. That's the whole thing. All right, let's do another one. So the trick to finding the substitution here, or finding the points of intersection, is just letting the two equations equal to each other. All right, so point of intersection, make the two equations equal. Right? So if I have this equation here, it's going to be equal to that equation there. Okay? We're just getting rid of the y, because we're going to say that y's are equal to each other. So we end up with negative 5x plus 2 is equal to x minus 4. And now, so once we've made them equal to each other, then we just solve by putting to either side, right? So let's keep, I'm going to move the x's to the right side this time. So this time, I'm going to add 5x, and I'll add 5x here. And these will cancel. So now I have 2 is equal to x plus 5x minus 4. But I also want to get rid of this 4, so I'm going to add 4. Whatever I do to one side, I have to do to the other side. So I end up with 2 plus 4 is equal to x plus 5x, because these will cancel. All right, so now I can simplify this, because now I have just numbers on one side. I got 6 is equal to 6x. And then I want to get rid of the 6 attached to the x. So I will divide by it. And x is equal to 1. So now that I have my coordinate, I have my x coordinate, I do the last part. I go up to here, and I take either equation. You can pick either equation 1 or 2. Let's pick equation 1. So y equals negative 5x plus 2. But instead of x, I'm going to insert that value in, which in this case was the number 1. So y equals negative 5 times 1 is negative 5 plus 2. And my final answer is y equals negative 3. So I'd wrap up by saying, therefore, the point of intersection is at your x coordinate of 1 and your y coordinate of negative 3. That's it. That's the answer. All right. So all we're doing is making them two equal to each other and then sorting it out by putting all the x's to one side and putting the numbers to the other side. That's essentially, that's it. Yeah, I'm trying to figure out how much stuff I'm going to get you to do today. I'll do a couple more examples, and then the rest is going to be for you. All right, so this one looks a little bit trickier. I'm going to do a tricky one for you. All right, this one's a little bit trickier, and we're not going to check it using Desmos. You can if you want. You can go to desmos.com if you want to and enter in those values. So this one's a little bit trickier because we're going to substitute in the y value, but we have to make it, so the first step here is we have to rearrange into y equals something. All right? So to do that, I'm going to make them both rearranged. So I'm going to do that one, and I'm going to do this one here. Okay, so this is going to be called equation 1, and here's equation 2. All right, so let's do equation 1 first. So right now it's negative 2x plus y equals 0. Well, all I want to do is get rid of that negative 2x right here. So I'm going to get rid of it by adding 2x. And whatever I do to one side, I have to do to the other side. So what I'm left with, these will cancel each other out. What I am left with is y equals 0 plus 2x, which is just y equals 2x. So that's equation 1. All right, so let's rearrange equation 2. And we had x minus y is equal to 12. All right. This time, I'm going to move the y to the other side. I'm going to keep the x where it is because I have this negative y here. So I want to move the y to the other side. So I'm going to go like this, plus y. And what happens is this negative y and the plus y will cancel out. And we'll end up with x equals 12 plus y. All right, now I just want to get rid of this negative 12. or sorry, this 12. So I'm going to subtract 12, but whatever I do to one side, I have to do to both sides. So my final answer there is x minus 12 is equal to y. Or you could rewrite it. It's the same thing as this. Y equals x minus 12. They're both the same thing. Doesn't make a difference. So now that we have equations in the form of y equals, we are going to let one side equal to the other, or one equation equal the other one. So now that we have both equations in the form of y equals, we let equation 1 equal equation 2. So 2x is going to be equal to x minus 12. And then we can just solve this. So we're going to solve that. So we want to get rid all the x's on the one side. So I have to get rid of, let's make them all go to the left side. So I'm going to get rid of this plus x here by subtracting x. Whatever I do to one side, I have to do to the other side. So plus x and minus x, they're going to cancel each other out. So I end up to 2x minus x is equal to 12. So 2x minus x is just, it's really just 1x, right? So that leaves me with 1x, or x, is equal to 12. All right, so we have one coordinate. Now we insert back into either equation. So let's go y equals 2x. We'll use the first equation. Y equals 2x. Y equals 2 times, and we're going to put in our value, 12. Y equals 2 times 12, which is 24. And our last part is saying, therefore, point of intersection at our x coordinate of 12 and our y coordinate of 24. All right, so sometimes you have to rearrange the equation to make it work. Now, this is just for x and y equations, but what if it was for something like cell phone plans or online music plans, right? So some have different costs, and you want to figure out which one is the better deal, or at which point are they both the same value deal. All right, so we have iTunes and MusicMine. They're two online music providers. So each company has a monthly membership fee and then a song per download rate. All right, so iTunes charges $10 per month and a $1 per song. And MusicMine charges $7 per month and $1.50 per song. So both of those equations are there. So we have equation 1 and equation 2. So find the number of songs that I would need to download where the costs are the same for the two music providers. So all we're doing is, again, making them equal, because C is already by itself. C, these two C's are the same, right? We're going to make these two equal to each other. So we're going to go x plus 10 is equal to 1.5 x plus 7. Now in this case here, x represents the number of songs. So, right, there's this one there. And there's your x plus 10. So we're going to consolidate them by getting them all go to one side. So I'm going to put all my x's on the left side this time. So I'm going to get rid of the 1.5x by subtracting 1.5x. And whatever I do to one side, I have to do the other side. So what I'm left with is 1x minus 1.5x plus 10 equals 7. Now I want to get rid of the 10, so I'm going to subtract 10. And whatever I do to one side, let's go to the other side as well. And these cancel. So I'm left with 1x minus 1.5x is negative 0.5 x equals, and then 7 minus 10 is negative 3. Now I want to get rid of those numbers beside there. So I'm going to divide by the number attached to x, which is negative 0.5. And I have to do it to both sides. And I get a value. So negative 3 divided by negative 5 is 6. And now that I have a value for x, I take either equation. Let's use equation 1 because it's simpler. And I can insert that value in for x. 6. So c is equal to 6 plus 10. C is equal to 16. So the costs are the same at $16, and therefore the number of songs is 6. So when you download 6 songs, all right, I'm going to leave it there for now. I want you to try the other ones on your own. There's some practice stuff that's in there. And you may have to manipulate the... Actually, this one's though pretty simple, actually. All of those are pretty good. So you can try the next one on your own. Yeah, that's it for now. I haven't posted a quiz yet. I will post it tomorrow. And it'll probably be like 3 or 4 questions again. Nothing too complicated. How was this one? This one was a little bit more complicated than all the lessons I've taught, I think. But if you have questions, let me know. I could always do more examples. How are we feeling about this one?
I'm good.
You're good? Okay, so give it some practice. Try it out on some of those extra questions there. And yeah, if there are problems, send me a message. I don't mind meeting online to go through it again. Yeah, just let me know, okay? And if you haven't done a quiz or a test, you can always go back and do it. I will always count it. There's no late marks or anything like that. So do the test and do the quiz. Got them?
Yep. Bye, thank you.
You're welcome. Bye-bye.